Parallel and perpendicular lines, we're going to go through what the differences are. So parallel, remember parallel lines, if I draw a line on a graph, so let's say I've got the equation y equals 2x plus 1 and y equals 2x plus 4. Then I start at 1, I go up 2 over 1, and that would be the first line. I do the same thing, and then this one I start at 4, 1, 2, 3, 4, go up 2 over 1, and there's that line. So parallel lines have the same slope. If you did a line, let's say there was another one, in this case it said negative 1/2 x. So there's no starting value. We would start at 0. That would be our intercept. And this one you go down 1 over 2. This line here is perpendicular, even though I can't draw perfect lines, therefore it doesn't look quite like a right angle, but perpendicular lines have right angles. So perpendicular, the symbol for perpendicular is an upside down capital T, and the symbol for parallel is 2 lines slanted. That's how we can remember parallel never intersect and perpendicular meet at a right angle. So if you look at the slope for perpendicular, you'll notice that the slope compared to the slope of 2, those 2 lines are perpendicular, and the 2 slope is perpendicular to the negative 1/2 slope. So what happens is if you put a 1 under the bottom of 2, it's the reciprocal the fraction gets flipped. That's what reciprocal means. It means flipped. And they're different signs. So this one's negative and this one is positive. Okay, so perpendicular, flipped, and different signs. So we're going to look at some of these problems. Here we've got 2 equations. We've got a slope of 8 and 8. So it's the same slope, therefore these 2 lines are parallel. This next one, notice that the bottom is not solved for y. So we have to move 9x over. They're not like terms, so I put it side by side. Y equals negative 3 minus 9x. So you see that the slope here is negative 9. The slope here is 9. They're not the same, therefore they're not parallel. But are they perpendicular? Well, they have different signs. But if I were to do the reciprocal of the number 9, I'd get 1/9. And since there's not a 1/9 there, this is neither. These are not parallel. They're not perpendicular. This is neither. Negative 9 and 9 would be neither. Y equal to 8. Since there's 0 x's, that's a slope of 0, and that's a line that looks like this. X equal to a number is a vertical line. So if you have a vertical and a horizontal line, that means these are perpendicular. Some more examples. So we've got a 1/2 and a negative 2. So if we're gonna compare 1/2 and negative 2, they're definitely not parallel because they're not the same number. And if you look at the signs, this one's positive, this one's negative. So that would be true for perpendicular. And are they reciprocals? Well, what number can you put under 2? A 1. So if you flip 1/2, you do get 2 over 1. These are perpendicular. The next one, we need to get rid of the 14 first here. So we'll divide out 14. So y equals 2 over 7 reduces to 2 over 14 reduces to 1 over 7. 28 divided 14 is 2. So I'm looking at 7 and negative 1/7. So again, we got negative 1/7. We're comparing to 7. Here, they're not the same, so it's definitely not parallel. This one's negative, this one's positive. So that works, but then do we have reciprocals? If you flip 1/7, you get 7 over 1, which in fact is the same as 7. So yes, these are examples of perpendicular. The next one, we have to solve for y, so we're going to add 3x to both sides. So we get 0. And then, so that's y is negative 7 plus 3x. Then I'm going to get rid of this. So for the bottom one, we have 3y equals negative 9x plus 21. We have to get y by itself, so we're going to get rid of the 3, divide it out on every term. Y equals negative 9 divided 3 is negative 3x. And then 21 divided 3 is 7. So we're going to compare this slope. We've got negative 3 compared to a positive 3. So if you're comparing, I've got negative, I got positive. And then if I look at the number 3, 3 is over 1. So if I do the reciprocal, I need a 1/3. I don't have a 1/3. These are not perpendicular. These are neither. That's not the reciprocal. This is neither. Okay, we're going to go through some examples. You want a line that's parallel to y equals 5x plus 1 that goes through the point 2, 6. So what this is actually saying is if you were to graph this, start at 1 and up 1, 2, 3, 4, 5 over 1. Pretend it goes through that point, and 2, 6 would be about here. We want a line that goes through this point that's parallel to, so this is 2, 6. We want a line through that point that's parallel to that other line. So we know that they have to have the same slope. What's different is the y-intercept. And we call that b. So what we're going to do is we're going to find a new b value. We're going to use x and y. And since we want parallel, we're going to use the same slope so that our line remains parallel. So m is going to be 5. So y equals mx plus b. Y is 6, m is 5, x is 2. So I times them out. 10, 6 plus b. I need to get 0, so I minus 10 to get b by itself. And 6 take away 10 is negative 4. So I've got b, I've got m. So the final thing we do is we write out the equation of the line that goes through that point that's parallel to the other given line. So these two lines are parallel to each other. I'm going to do another example, same thing, parallel through y equals 3x plus 1 through the point 1, 5. So again, we need, if we're going to look at a graph of that, that'd be up 1, 1, 2, 3 over 1. We want, there's the line, and 1, 5 would be up here. So we are looking for a line that's parallel to that through that 0.15 that's parallel to the y equals 3x plus 1 line. So if we need it parallel, we need the same slope. We're going to use m is 3. We need it to go through the point, so there's x and y. We need that to be a solution. And y equals mx plus b, we're going to find that new y-intercept. So y is 5, m is 3, x is 1. We've got 3 minus 3 minus 3. So on this one, that y-intercept is 2. And if you look at the graph, it's pretty close to 2, I guess, where I drew the line. But so our equation that goes through the 0.15 and its parallel is 3x plus 2. One more example of parallel. I'm going to go through this one quicker. So we want parallel, so our slopes are the same, so that the lines will be parallel. We've got x, we've got y. So y equals mx plus b, negative 3, 2/3, x is 3 plus b. So here, the 3's are going to cancel. We've got 2 plus b. I minus 2, so negative 5 is our y-intercept for our new line. So y equals 2/3 x minus 5 is parallel. I'm not going to do another parallel example. We're going to go to perpendicular now. So on this one, if we want perpendicular, 1, 2, 3, 4, 5, 6, 7. So we want it perpendicular to y equals 2x plus 7. So that would look something like 2x plus 7 looks like this. And it needs to go through the point 4, 1. So here's 4, 1. And this time we want perpendicular, not parallel. So that means that we want a line that goes through that point and is perpendicular to that line. So we're going to find the equation of that line. We know that this one is y equals 2x plus 7. And if we want the line to be perpendicular, we know that the slope here is 2. So the slope here, we need the opposite sign. So this one is going to be negative. And if you take the reciprocal, we're going to have negative 1/2. So we need to use the slope of negative 1/2. We need it to go through the point 4, 1. And we're going to find the new y-intercept. So we got y equals mx plus b. We're going to do 1, negative 1/2, and 4. So half of 4 is 2, and negative positive would make negative 2. And then I add 2 to get 0. And that means b is equal to 3, which actually I drew the line so that worked out. So the y-intercept is 3. We know that the equation is then negative 1/2 x plus 3. That's the equation of the line through the point 4, 1, perpendicular to that line. Okay, again, another example, perpendicular. So if I draw a rough sketch of this, so up 7, down 3/1, looks something like that. Y equals negative 3x plus 7. Okay, and we have the point, so 3, 5 is somewhere over here. And what we're trying to do, we want a line perpendicular to this line that goes through the point 3, 5. So we know that we have a slope here of negative 3. So if we need perpendicular, we need to change the sign to positive and then take the reciprocal. So the reciprocal of 3 is 1/3. So I'm going to use 1 over 3 as the slope. We need it to go through the